Simplified this basic first so that we understand what actually you can convert and what you can't, what are the relationships, and so forth. So, oops, no. Okay. All right, so once you halfway close your computer, I'll know you're ready. Right, so eyes are coming up here in just a second. Okay, we're going to go over those ones at 1 through 8, but give me a second before we go there. Because you really need to see there's only 3 relationships that you can absolutely make. Now, the other ones that we self-created yesterday with atoms to molecules, that was because we had some background knowledge on bonding. We could look at a structure and go, oh yeah, 3 atoms of oxygen and 1 molecule of sulfur trioxide. But really, there's 1 mole, which is, what is a mole again? A unit of measurement that really tells us what? But what is that? It's just a number, right? It's just a quantity. A mole is a quantity. Like a dozen is a quantity. Like a baker's dozen is a quantity. Like a, what's another word that means a number? Couple. A couple, right? It's a quantity. So all these things, there's words that mean a number. But that number, which is 6.022 times 10 to the 23rd, when I say that, what am I actually describing? Number of what? Most of the time we're signifying some number of particles. Particles come in 3 flavors, and so I'm always going to draw it this way so that you memorize the same sequence. So the particles come in three varieties. What are they? Atoms, molecules, and formula units, okay? And those are just terms that we use with different types of compounds. So if I'm saying something that's covalently bound, which word do I usually use? Molecules. If I'm saying something that's simply an element, atom, and if I'm saying something ionically bound, formula unit, okay? So there's only one way to get from particles to moles or vice versa. This is a double-headed arrow. It's using the number 6.022 times 10 to the 23rd. So you'll never, ever write that number with grams. You'll never write that number with liters. It'll only be when you're describing an atom, a molecule, or a formula unit. So if you start to write that number and you're going to write some other unit, you've chosen the wrong number. You've selected something incorrectly. Okay, so the secondary relationship, this is just between numbers and numbers of things. You can also relate the mole to a mass of that specific thing. So we call that molar mass. And where do we get that information from for any compound? Periodic table. So we're going to have the number of grams per 1 mole, because remember everything's per 1 mole, and there's no number there because we have to pull information from the periodic table. So when you're writing grams, will you ever write 1 gram? Probably not, unless you're talking about just 1 atom of hydrogen, like, or 1 mole of hydrogen weighing 1.008. But usually you'll write 1 mole per 70 grams, or 130, or 152, or some other random number, because you have to add it up from the periodic table. All right, so last one is what? So hold on, molar volume. And what are the conditions that we really talk about this at?
0 degrees Celsius.
All right, I heard STP, and when that is 0 degrees Celsius and 1 atmosphere. What do we talk about when we talk about this volume? What specific state of matter? Gases. Okay, so it's only for a gas at STP. Okay, so this, we're talking about like a large amount of space. And so we say if we had a mole of gas, it would take up how much space? 22.4 what? Liter. So will you ever write 22.4 with another unit? Probably not. Okay, liters, that's it. So this is going to be your go-to. And so I'm going to have you guys, if you guys had this from yesterday, pull it out for me. Because I'm going to make you follow along the railroad tracks. Because you can't go between particles, mass, and volume. You have to always go back to the mole and then track forward if you need to track forward. It's like a map. You have to follow the map. Okay, so I went ahead and tracked out some of the work. We did talk about 1 through 3 yesterday. So on 1 through 3, first off, I think we're still struggling with nomenclature. Identify the type of compound this is. Ionic, covalent, or acid. Ionic, so you took your ions, you crisscross your charges, boom, we've got chromium 3 oxide. What was your molar mass of that? 151.98. I remember this from yesterday. Okay, so we did this. You guys got your answer. Do I need to go over that one? We did this yesterday, intervention. Okay, moving on. So the next one I did not do. So on on, is my board alive? Okay. Hold on, guys. Promises. I told you I could work this thing. Ha, I have to touch that. Okay. So if I have moles already and I'm trying to get to grams, okay, which of these am I following? Where am I starting? I'm starting where? I'm at the mole here. I'm here. Where am I going? To your mass, right? There's only one relationship that touches between those, and that's the molar mass of, in this case, who? Potassium. So you pull that information from periodic table, plop it on your little division symbol, and you got your basic work. So we have our mole of potassium, 1 mole of potassium, like you said, for your connection there. Those will cancel, and your grams of potassium lives on. Okay? So what is that? 129 point what? 812 grams of potassium. Take that sig figs. How many sig figs should I have? Say again? 3 sig figs, because there's 3 sig figs here. This one has more than 3 sig figs, so we're going to go ahead and go to what? 130 points. That gives me that 0 as significant, so I do keep it there. Wonderful. Okay. So far, so good. Those were single step ones, okay? And I know number 7 is what the struggle bus ones, so we're getting there in a second. We did number 3 yesterday. Let's actually look at this first and then track it on our mole map. What are we starting with? Molecules. What am I ending with? Grams. Okay, so is there a direct connection between molecules and grams? No, you actually have to go through what first? You have to go to what? Moles. So if I'm up here at molecules, I can't go straight to grams. There's no connection there. So I have to go from particles, aka molecules, all the way through mole using what number? Okay, so I have to know how to write it, but I know that's going to go with the molecules, and then 1 mole goes with the 1 mole. And then once I get from moles, where was I going? Grams? So I can go to grams of that by using the next conversion type, which is our periodic table mass. So it is a map. It does help you if you think of it that way. Okay, so we did this part yesterday. We took our molecules. We cancel molecules. The number, Avogadro number, goes with molecules. So those cancel. The mole of CCl4, carbon tetrachloride, is here. I need to get that to grams, so I add up the masses, put the mass on top, mole on bottom, mole cancels here and here. And so you guys did that yesterday. I don't remember what the answer was. It was like something to the negative 40 something, 1.2 times 10 to the negative 46, something like that. I'm more worried about the process right now. That's why I'm not always writing my answer up there fully. Okay. So this is where the new stuff comes in. Calcium nitrate. Raise your hand if you're confident. What's calcium nitrate? Cassandra. Good. Give me a thumbs up if you got that. Okay. Please, please, please reference your periodic table. Calcium is a 2 plus charge. Look at your polyatomics until you're really confident. NO3 1 minus. So when you do your crisscrossing, you get CaNO3 2. So pausing there kind of says parentheses. Is there a direct conversion between mole and grams? Yes. So how many steps will this take? 1. But the only thing is, you had to get your formula right to get your mass right, right? So what was the true mass? 164.1, something like that. So if you put NO2 there, your mass would differ, which means your final answer would differ. So I'm walking through process first to make sure you have the basics. So the mole cancels with the mole, the grams goes on top. All right, keep rolling. Because you guys can put in your calculator. Okay, moles to liters. Is there a direct conversion between moles and liters? Yes. How many steps will this take? 1. Using what number? 22.4. So is this going to be a full 22.4 liters? No, like 87% or so. Like I don't know. 18. What's the final? 19.6. Okay. So you have your N2, which is a gas. We have a mole of that. 1 mole on bottom cancels. 22.4 liters of that same gas on top. It's a single step conversion. Okay, keep going. The single step ones I'm not spending a lot of time on. Here comes the more complex ones. Okay, so first off, carbon dioxide formula. CO2, and you recognize it as ionic, covalent, or acidic. Covalent. So if the prefix is next to that letter, that goes with that letter, or goes with that symbol. So is there a direct conversion between grams and liters? No. Go back to your mole map. Grams to liters. You go back. You reference this. Where's grams at? In the middle. Okay, so what do I have to do? So how do I convert to moles? So I have to go to the periodic table, look for carbon dioxide's mass, and use that to get to moles. And then moles to what? Liters. How do I get to liters? 22.4. So it is a map. You're going from grams to moles, moles to liters. So keep thinking it like that, and you guys should be good. Okay, so what's the molar mass of carbon dioxide?
It's
44.01. 44-ish. Should be 44-ish. Carbon's 12 plus 32. It's about 44. So the grams of carbon dioxide cancel with the grams of carbon dioxide. That number is specific to carbon dioxide. The mole of carbon dioxide remains, and then the mole has to be canceled by the next fraction using 22.4 to get to the liters. What was your final answer here, guys? 2 point what? 31-ish liters of CO2. And that makes sense because that's about half of that. So half of 4.5 is about 2.5. So, or 2.2. So that sounds good. Okay, last two. So on this one, I'm going to do it two ways because I want to do one that really, really makes sense to you, and then I'll show you a trick so that you can see how you can shorten your work. Hydrogen peroxide's formula is H2O2. All right, so likely we see that we're starting with moles, so we can go anywhere for moles, right? But you cannot go straight from moles of hydrogen peroxide to grams of oxygen because that's comparing apples to oranges. We need to go apples to apples and then go inside the apple and get the apple seeds out. Like we need to look inside of that molecule. So if I'm going from moles to grams of oxygen, I can't get to grams of oxygen without having already gotten to what of oxygen? What's going to be before I get to grams of oxygen? Probably moles. If I'm in grams of oxygen, I couldn't have just gotten there from nowhere. I likely was already at moles of oxygen, right? Okay. How would I have gotten to moles of oxygen? What maybe would have came before that? I'm trying to see if you guys can pick up what I'm putting down. How would I have had a singular oxygen? What would I call that singular oxygen? An atom of oxygen. I probably was at atoms of oxygen before I got to moles of oxygen, because that's the only way I probably would have been able to get to moles. Okay, so how would I have gotten to atoms of oxygen? Because it's in a bigger picture, right? What's it in? Oxygen's inside a molecule of H2O2 because that's what a covalent compound is called. It's called a molecule. So how did I get to atoms? I probably did that little dissection thing. It was like, oh, in H2O2, there's two atoms. So in one molecule of H2O2, there's two atoms of oxygen. So we're looking at the ratio. So molecule of H2O2. Okay, well then from moles, how did I get to molecules? Okay, so I probably went from moles to molecules using Avogadro's number. All right, so we kind of backtracked there, but that's like, what, 5 steps almost? Let's see what that looks like first and see the cancellation, and then look for simplification. So I'm starting off with my, don't get scared, it's here, okay. So I start with my moles of H2O2. I logically know I have 3 options. Go to molecules, go to grams, or go to liters. Grams and liters don't really help me a whole lot, right? So I need to actually go to the particle sense. So moles to molecules, 6.02 times 10 to the 23rd molecules per 1 mole. That mole cancels out. Now I've narrowed down to just a molecule, just one H2O2 sitting in front of my face. So in that one molecule, which kind of looks like this, we actually never drew hydrogen peroxide, but that's what it looks like. I can see in that one molecule I have 2 atoms of oxygen. So that's kind of like my self-made conversion because I have to look at the molecule itself. So the molecules of H2O2 cancel. Now I'm in the atom, or the smallest level of oxygen I can get. Well, I don't have an atom to gram relationship, right? Atoms are up here on top of the chart, grams down here in the middle. So how do I get from atoms to grams? Yeah, you gotta go back to mole and then to grams. So that's why I went from atoms, using 6.02 times 10 to the 23rd, atoms of oxygen, back to mole of oxygen. And that's because I'm in my singular state of oxygen. So atoms of oxygen cancel. mole of oxygen lives on. 1 second. And then I took my final step for mole to just simply mass up the plain old oxygen, and that's 16 grams from the, how do I know that? Periodic table. And my mole cancels out. What's up, Will? So that's where you have to think outside the box a little bit and go from, how do I get from a molecule to an atom? And that's the question, because that's not on our mole map, right? We don't have that. That's what we have to think about. Like, what is a molecule? It's a combination of atoms. So if I have a molecule of H2O2, all together, that's one molecule. But inside of that, think of who likes Reese's? Okay, my favorite candy. Okay, so when you buy it, you get one package, right? So what's in it? 2 Reese's cups, right? So if I have one package, I still have 2 things in that package. I have 2 atoms of oxygen in that package, or 2 Reese's cups in that package. So that's your self-made conversion. It's not on your mole map. So you have to just kind of think outside the box there, okay? Okay, so what do you notice I put up there twice? What number? So I basically was redundant. Like I put it up there on top and I put it on the bottom. So basically those cancel each other out, right? So there's actually something called an internal mole ratio, and I'll show you that here now, because that's a lot of work. Sometimes we don't have time for that level, okay? So we're going to try to look at this as a mole ratio instead. So this right here, 0.0160 moles of hydrogen peroxide. Okay, a mole is just a number, right? So in that, let's just say I had 1 mole of H2O2. Relatively, how much oxygen do I have? The same amount of oxygen? Triple, double, quadruple that I have of this. So if I have 1 Reese's cup, let's go with that. One package of Reese's. How many Reese's cups do I have? 2. So for every, so let's say I had 500, ooh, that'd be great. 500 packages, how many Reese's cups do I have? 1,000. So what are you doing? Just multiply by 2, because you know inside of that package, how many Reese's cups are in there? 2. So inside of this package of H2O2, how many oxygens are in there? 2. So if I have 0.016 moles of this, how many moles of oxygen do I have? Double that, because I have 2 of them for every 1 of these. So I actually can see that doubled gives me the actual moles of oxygen I truly have here without going through boom, boom, boom. I actually take out these 3 steps. Okay, I do need the last one because it's got the moles, but basically I go from mole, and then I say, oh, inside of that, I've got, in 1 mole of H2O2, I can have 2 moles, or 2 times the amount of oxygen. So that right there is an internal mole ratio, because I'm looking at this 2 right here for every 1 of these. And so that's that's more advanced, okay? But it does get you past redundancies. And so then my last step would be to get to grams, which would be moles of oxygen to grams of oxygen, which would be what step? Molar mass, right? Still 16 grams of oxygen for 1 mole of oxygen. So I wouldn't use that unless I was really comfortable with all this stuff, because this is an advanced, special way of solving. Okay? All right, let's pause there. You guys are getting sleepy on me. I want you guys to get up and name off as many polyatomics you can. Go. Find somebody else to talk to. Get up, get up. Each other. Sorry. Please each other. We're breathing. Oh, and there's that one that's C2H. Wait. Yeah. All right, pause. Don't do ionics now. Go to covalence. Talk about covalence. You got 30 seconds because those are easy. Name off covalence. Pause. Do binary acids. Binary acids.
Wait, I thought it was just two molecules. I know the. Oh, yeah. Like H2O. Wait a minute, what? So it has to be an acid. It has hydrogen. That does have hydrogen. So it would be like H, it would be H, and then whatever. I don't know. I'm not sure why. I don't know what I'm doing. I'm gonna get the I don't think so. Wait, so when did you get on the quiz? No. Better than I did. I don't know. Got my sports
Alright, ternary acids. Ternary acids. Those are the ones with the polyatomics in them.
Oh yeah.
So you drop that
I said hours. I know that, but I don't know.
It's like nitric acid, you go to nitric acid. Nitrite acid.
At least we get 3 tries because what did you do yesterday? Wow, why would you do worse today? That doesn't make sense. Do we have one tomorrow? Do we have one tomorrow? Yeah. There's no. That's so true. I wanted to go outside. I have no protection from the elements. I'm in under my mom's ex-boyfriend's t-shirt. Well, my brother's shoes. I can't. Is it really? Yeah. We wear the same size. Oh my god. So I take his Converse off. Yeah. Every time like it's fat, but you can't pull it off. Like it like sticks up in the back.
He's actually studying it, he's just talking. Because I'm ready.
We were.
Okay. Take one more minute, guys, and then you are spreading out and moving on. 1 more minute.
Oh no. Yeah. But it's what? But it's just flat C.
All right, move to another location. Clear off your desk. Oh, 9. I'm passing up periodic tables for you. Put everything else away. 8. 7. Move to another location if you need to. 6. 5. 4. 2. 1. Please begin as soon as you can. I know it's slow. So I'm giving you periodic tables, so you don't even need the blue ones. Yes, right on this. And it should not take you more than about 5 or 6 minutes. I'm just saying, I said should. I said should. I mean, if you give you the time, I think you need. itemizing in your head or categorizing in your head or on the sheet after you still gotta speak. Which ones are ionic, which ones are covalent, and which ones are acids, because you should have those classified in your head that way. One more tip, sorry to see some wrong answers. I would put some parentheses around the polyatomics in the formulas so you can really see what the charges are or think about what subscripts form. They do recommend parentheses on polyatomics. once you're done, you can bring